Hey guys, if you're watching this right now, it's because either you are getting this for some extra added review and reinforcement from what we did in class, or you were absent when we covered this in class. So make sure that if you still have any questions after you watch this, that you are getting those questions answered during class.
So first of all, we need to go through some vocabulary. So we need to know what degree is. Degree is the highest exponent value in a function.
In terms of this unit, all of ours, this unit will be a degree of 2.
And behavior, the direction of the ends of the graph of a function.
So we learned this in Unit 4. If it's a positive function, it's happy, it's opening up. If it's negative, it's sad, it's going down.
Axis of symmetry is the vertical line that passes through the vertex of the quadratic function.
It splits that parabola in half.
Important pieces to a quadratic function are as follows. Degree always is 2 in a quadratic function.
So remember when we talked standard form, ax squared bx c, because it is squared, that's the highest degree, therefore that's why it is a degree of 2.
Shape, always a u in a quadratic function called parabola.
So every single time I ask you for degree, I'm looking for name, or the degree and the shape. So it'll always be 2 and parabola.
End behavior, will it open up or down? Axis of symmetry will always be x equals
something.
Something.
So we're going to talk in a little bit about what that something is.
Vertex, critical point. This is the max or min point, max if opening down, min if opening up.
So we call a vertex a critical point because it's an important point within the graph.
X-intercept, where it crosses the x-axis. And then we have y-intercept, where it crosses the y-axis.
And then also one thing that's not on the list are obviously domain and range. They're just not critical pieces to the graph. They're just critical pieces of information. So we're going to start off taking a look at a graph in which I don't give you the equation, I just give you the graph itself. Our degree is going to be that 2, and it's going to be a parabola for spelling. End behavior, clearly this one opens up because it opens up, it's like a bowl. Axis of symmetry, I've drawn it in as that green dotted line. If you count over, it's 5, so this would be x equals 5. Our vertex is this point right here. It's listed right here, so our vertex would be 5, -2. Our x-intercepts are where it crosses the x-axis here and here, so it would be 2, 0, and 8, 0. And y-intercept, where it crosses the y-axis here at 0, 4. It's pretty easy to find all this information when it's already graphed for you. Now we're going to give you the equation, and you've got to be able to graph it.
So the steps to graphing are as follows. Degree, name and shape.
So as we've mentioned, that will always be 2 and parabola.
Does it open up or down? And we can find that information from our A. If it's positive, it opens up. If it's negative, it opens down. Find the axis of symmetry. So we have x equals opposite b divided by 2a.
Remember, that's opposite of b, not negative b, because otherwise you're going to get stuck keeping it negative if it's already negative. So what we mean by b and a are the a in front, the coefficient in front of x squared and x. And make sure you always double it, and then we write it as x equals.
And then find the vertex. We have to take what we found for the x-axis of symmetry, use that, and substitute it in for x.
So we put it back into our function, and that's what this f of opposite of b over 2a, it just says, just like f of x is y, this is our y coordinate. We take what we got for axis of symmetry, we substitute it back into the function to get our y coordinate, and we put them into an ordered pair.
And then to find the y-intercept, it's 0, c.
One thing I don't have in here that I want to add in This is also going to be finding our x-intercepts. And our x-intercepts, remember, we can do that. First of all, first attempt will be by factoring. If we cannot factor it, you're going to probably, I'm not even going to include completing the square because most of you will find it easier to just do the quad formula, but you can also complete the square.
And then we have the domain and range.
And if you remember, domain will always be negative infinity to positive infinity. Your range will all depend on whether it opens up or opens down. If it opens up, then it will be a square bracket with your y-coordinate of your vertex to infinity. If it opens down, then it will be from negative infinity to your y-coordinate with a square bracket. So now that we have that, let's go ahead and try an example. That example here is x squared plus 6x plus 5.
So my degree is going to be 2, and we're going to have a parabola. And since our x squared is positive, we're going to open up. And then we need to find our axis of symmetry. So we're opposite of b, so we would have 6.
But it's opposite, so we make it negative.
And then we would have over 2 times 1.
2 times 1 is 2. Negative 6 divided by 2 is negative 3. So we would write our answer as x equals negative 3.
And then to find the second part of our vertex, we need to take the negative 3 and substitute it in for our x value above.
And so we take negative 3 squared, we get 9. 6 times negative 3 is negative 18. And here's how you tell if you have a correct axis of symmetry. When you substitute it in and start figuring it out, your first term should be half of your middle term of your trinomial. And they should be, so the second one should be double, and they should be opposite signs. 9 is half of 18, and 18 is negative 9 is positive, so we know we did it correctly. 9 minus 18 is negative 9, plus 5 is negative 4, which means that my ordered pair is going to be negative 3, negative 4.
And then for the y-intercept, we have to look at our c value and find it as 5, so we're going to say 0, 5.
And then domain, like we said, is always negative infinity to positive infinity. Because our graph opens up, we know our range is going to go from a square bracket to positive infinity. Our y-coordinate was negative 4, so it's from negative 4 to infinity. Now we just need to graph. When we graph this, we graph all of our important pieces. We start with our axis of symmetry, so x equals negative 3. So we make a dotted line. Please make yours straighter than mine at that point. And then from there, we just graph our points. We have a vertex at negative 3, negative 4. We have a y-intercept at 5. We want to, and here's the catch. We don't have our x-intercepts, so we need to find our x-intercepts. In our case, we have a trinomial, so I'm going to try a t-table. Multiplies to 5, adds to 6. Luckily, this factors, so we can get 5 times 1, because that checks out adding up to 6. So that means I have x plus 5, x plus 1. Well, if I set these both equal to 0, x plus 5 equal to 0, that means x is going to be negative 5, and x plus 1 equal to 0 is going to be x equals negative 1. So that means that my x-intercepts are going to be negative 5, 0, and negative 1, 0. So I plot those as well. So negative 1, negative 5, they should be equally distant from the axis of symmetry. Well, we need 5 points, though, to graph a parabola. And because we have an axis of symmetry, everything should have a mirrored point. The zeros match each other. Our y-intercept does not have a mirrored point. It is 3 units from the axis of symmetry, so we need to go 3 units the other way and plot our point. And then we have our points to be able to make our parabola. Make sure you make it nice and round at the vertex. So that's all there is to it. What I want you to do now, if you haven't already, is give this U-trigram a shot. You're going to find degree, end behavior, axis of symmetry, vertex, y-intercept, x-intercepts, domain and range, as well as graphic. And make sure you bring those questions with you to class tomorrow.